This is Fundamentals of Electric Circuits, 5th edition, Chapter 4 Solutions, from question 66 to question 73. Question 66. Find the maximum power that can be delivered to the resistor R. To find RTH, we have to short circuit all the voltage sources and open circuit all the current sources, and we have to remove the load resistor R. On doing so, RTH is equal to 2, which is parallel with 3 plus 5. So which is equal to 2 is parallel to 8. On doing the simplification, 2 into 8 divided by 2 plus 8. So RTH is equal to 1.6 ohms. To find VTH, we apply source transformation to the original circuit. V is equal to IR, which is equal to 6 into 5, which is equal to 30 volts. So on applying KVL to the loop, 2i minus 10 plus 5i minus 30 minus 20 plus 3i is equal to 0, which results in I is equal to 6 amps. Now on applying KVL to the loop ABCD, we get 2i minus 10 minus VTH is equal to 0. On substituting the value of I, we get VTH is equal to 2 volts. To find maximum power, we use the formula VTH square by 4 RTH. On substituting the values, 4 divided by 4 into 1.6. So the maximum power is 625 milliwatts. Question 67. The variable resistor R in the figure is adjusted until it absorbs the maximum power from the circuit. Calculate the value of R for maximum power. Determine the maximum power which is absorbed by R. Now to find RTH, we have to open circuit all the current sources and short circuit all the voltage sources, and on doing so we get 20 is parallel with 80 ohms and 90 is again in parallel with 10 ohms, and the resultant of the two are in series. On doing the simplification, 20 into 8 divided by 100 plus 90 into 10 divided by 100, which results in 16 plus 9. So RTH is equal to 25 ohms. To find VTH, we apply KVL to the loops 1 and 2. So on applying KVL to loop 1, it results in 80 plus 20 of I1 minus 40 is equal to 0. I1 is equal to 0.4 amps. Similarly, applying KVL to the loop 2, we get 10 plus 90 of I2 plus 40 is equal to 0. So I2 is equal to minus 0.4 amps. Applying KVL to the full circuit, we get minus 90 I2 minus 20 I1 plus VTH is equal to 0. On substituting the values of I1 and I2, we get VTH is equal to minus 28 volts. R is equal to RTH, which is equal to 25 ohms. Pmax is equal to VTH square by 4 RTH. On substituting the values, we get minus 28 the whole square divided by 4 into 25, which is equal to 7.84 watts. Question 68. Compute the value of R that results in maximum power transfer to the 10 ohm resistor in the figure. Find the maximum power. Removing the 10 ohm resistor, we get R and 20 are in parallel. So RTH is equal to R into 20 divided by R plus 20. So VOC is equal to VTH, which is equal to 12 into 20 divided by R plus 20 plus minus 8. As R goes to 0, RTH also goes to 0, and VTH is equal to 4 volts. So P is equal to VI, which is equal to 4 square by 10, which is equal to 1.6 watts, which is the maximum power. Question 69. Find the maximum power which is transferred to the resistor R in the given circuit. To find VTH, We apply the nodal analysis at the node 1. We get 100 minus V0 by 10 is equal to V0 by 40 plus V0 minus V1 by 22. Similarly, doing for the second node, we get V0 minus V1 by 22 plus 3 V0 is equal to V1 by 30. On solving 1 and 2, we get minus 243.6 volts. To find RTH, 10 is in parallel with 40 ohms, which results in 8 kilo ohms. So 8 and 20 kilo ohms are in series, which results in 30 kilo ohms. So on applying nodal analysis at node V0, we get 1 plus 3 V0 is equal to V1 by 30 plus V1 by 30, which is equal to V1 by 15. So 15 plus 45 V0 is equal to V1, but V0 is equal to 8 into V1 divided by 30. Substituting this value, we get 15 plus 45 into 8 into V1 by 30 is equal to V1. So V1 is equal to minus 1.3636 volts. So RTH is equal to V1 minus 0 by 1, which is equal to minus 1.3636 kilo ohms. So as RTH is negative, it indicates an active circuit, and if you now make R equal to 1.3636 kilo ohms, then the active circuit will actually try to supply infinite power to the resistor. So Pmax is equal to VTH square by minus 1363.6 plus 1363.6 the whole square into 1363.6. On doing the simplification, we get Pmax is equal to infinity. Question 70. Determine the maximum power which is delivered to the variable resistor R. From the above diagram, we find Vx is equal to 0 as it is an open circuit. So VTH is equal to 4 into 15 divided by 15 plus 5 based on the voltage division rule. On doing the simplification, we get VTH is equal to 3 volts. Now to find the RTH, we apply the nodal analysis at the node 1. We get 4 minus V1 by 5 is equal to 3Vx plus V1 by 15 plus V1 minus V2 by 5. So Vx is equal to 6 into 1, which is equal to 6 volts. Substituting this value in the first equation, we get 258 is equal to 3V2 minus 7V1. So let us consider this as the first equation. So similarly, applying the nodal analysis at the node 2, we get 1 plus 3Vx plus V1 minus V2 by 5 is equal to 0. Similarly, substituting the value of Vx in this equation, we get V1 is equal to V2 minus 95. So let us consider this as a second equation. On solving the first and the second equation, we get V2 is equal to 101.75 volts. So RTH is equal to V2 minus 0 by 1, which is equal to again 101.75 ohms. So Pmax is equal to VTH square by 4 RTH. On substituting the values, we get 22.11 milliwatts. Question 71. What resistor connected across the terminals A and B will absorb maximum power from the circuit? What is that power? So we insert a 1 milliamp source at the terminals A and B as shown in the above figure. Now applying at node A, we apply the nodal analysis. We get 1 is equal to VA divided by 40 plus VA plus 120 V0 by 10. So 40 is equal to 5 VA plus 480 V0. The loop on the left side has no voltage source, so V0 is equal to 0. So substituting this value in the first equation, we get VA is equal to 8 volts. So RTH is equal to VA divided by 1 milliamps, so which is results in 8 kilo ohms. To get VTH, consider the original circuit. for the left loop. On applying KVL to this left loop, we get V0 is equal to 8 by 4, which is equal to 2 volts. So for the right loop, VR is equal to VTH, which is equal to 40 into minus 120 V0 divided by 50. So substituting the value of V0 as 2 volts, we get minus 192 volts. The resistance at the required resistor is R is equal to RTH, which is equal to 8 kilo ohms. P is equal to VTH square by 4 RTH, so which is equal to minus 192 the whole square divided by 4 into 8 into 10 power 3, which results in 1.152 watts. Question 72. Obtain the Thevenin equivalent at terminals A and B. Calculate the current in RL, which is equal to 8 ohms. Find RL for maximum power which is deliverable to RL. Determine the maximum power. Now to find RTH, we have to short circuit all the voltage sources and open circuit all the current sources. On doing so, RTH is equal to 2 plus 4 plus 6, as all the 3 are in series, which results in 12 ohms. Now to find VTH, on applying KVL to the loop, we get minus VTH plus 12 plus 8 plus 20 is equal to 0. So VTH is equal to 40 volts. Now I is equal to VTH by RTH plus R, which is equal to 40 divided by 12 plus 8, which is equal to 2 amps. R is equal to RTH, which is equal to 12 ohms. P is equal to 40 the whole square by 4 into 12, which is equal to 33.33 watts. Question 73. Determine the maximum power that can be delivered to the variable resistor R. RTH is equal to 10 parallel to 20 plus 25, which is parallel to 5. Doing the simplification, we get 325 parallel to 30, which is equal to 10.833 ohms. To find VTH, VA is equal to 20 into 60 by 30 based on the voltage division rule, which results in 40 volts. VB is equal to 5 into 60 by 30, again based on the voltage division rule, which is equal to 10 volts. So minus VA plus VTH plus VB is equal to 0 and applying KVL to the loop, and VTH is equal to VA minus VB, which is equal to 40 minus 10, which is equal to 30 volts. So P max is equal to 30 whole square by 4 into 10.833, which is equal to 20.77 watts.